Hello everyone. So let's solve today's problem, lowest common ancestor in a BST. So in this problem, we have been given a BST and all we have to do is to find the lowest common ancestor of the two nodes. So the two nodes will be given to us and we have to find which is the lowest common ancestor. So let's look at the first test case in which we have been given this BST, and what approach I'll be following is, since we know in BST the element larger than the root lies on the right and the element which is less than the root element lies onto its left. So we have to find the LCA, lowest common ancestor. So initially we are standing at the root, which is 5, and we check if we can go any in the any deep in this tree, since we have to find the lowest common ancestor. So we have to go until we we get a tree like this. So we search for, since this is, let's say this was n1 and this was n2, and in that case this root element was our lowest common ancestor, since it is it has the children n1 and n2, right? But so let's not look at the first test case, let's look at the second one. It is quite simple, in which we have been given the tree like 2, 1 and 3. So lowest common ancestor of 1 and 3, as you can see, is 2. So what will be the case if we don't have the subtree like this? For example, if the nodes are, since let's consider the skew tree. Right, this is right skew tree in which there is no left node. So what we'll do is we check for if 5 is between our n1 and n2, means the value of 5, as you can see, the 2 had the value 1 at its left and 3 at its right. So in that case, this was our result. So the same approach I'll be applying here, in which the 5, here the 5 is not in the range 7 to 8, right? So what do we do? And the 7 and 8 are greater than 5. So we simply make the right call. So we go on to right in the search of lowest common ancestor, and we see this 6. Again, this 6 is not in the range 7 and 8. What do? We again make the right call. And once we get on the node, which is 7, 7 was our n1 and 8 was our n2, as you can see. So as soon as we reach one of the nodes, this means that there is no parent which is lowest common ancestor. There is nothing present. So what do we return? We return simply that node. Okay, so I hope you get the idea. So this is the implementation. If there is no root, then we return null. And if the root's data is greater than n1, means if 5 was greater than 7 and 5 was greater than n2, which means that our root data is greater than n1 and n2. In that case, we should move left because we have a greater value on the root, and on the left side we have lower values, right? So we'll move left. We'll make a call on the left. And again, we check if the root's data is less than. Similarly, like the case one, we have if the roots data is less than, then we should move on to right. And if the roots data is lying in the range n1 and n2, we simply return. And this case also includes the case when there is no lowest common ancestor. So as soon as we reach any of the nodes n1 and n2, we simply return the root. Okay, so as you can see, it runs pretty well. All right, thank you.